Hello, this is a video for EDX Statistics 1. It is the second video in this series and it will cover the goodness of fit test for the binomial distribution. Here is a quick recap of how to carry out a goodness of fit test. First of all, you need to determine which distribution would be most appropriate and decide on your significance level. Then you need to estimate any parameters from the observed data, form your null and alternative hypotheses, and calculate expected frequencies. For those expected frequencies which are less than 5, they need to be combined into other cells. Find the number of degrees of freedom, which is the total number of cells minus the number of constraints. Find the critical value of chi-squared from tables or a calculator, and calculate your test statistic. Then draw your conclusion based on whether that test statistic is significant or not. This video is only going to cover the goodness of fit test for the binomial distribution. Here we have some data which is thought to be modelled by a binomial distribution with n is 10 and p is 0.2. We're asked to conduct a test to see if this is a good model using the 5% significance level. So here are our hypotheses. H0 is that the binomial distribution with n is 10 and p is 0.2 is a suitable model for these results, and H1 is that it is not. The first thing we need to do is calculate probabilities from the given distribution. You can do this from tables or your calculator, and you can see here I've calculated the 10 probabilities from GeoGebra. The next thing we need to do is calculate the expected values for this distribution, and we do this by multiplying by the total frequency of the observed values. In this case that's 100. So multiplying each of these probabilities by 100 gives us the following expected values. You will notice that the values which are bigger than 4 are all less than 5. That means we need to group them together to create a category which has an expected value of greater than or equal to 5. And in this case they're all going to have to be grouped so that our top category is greater than or equal to 4. I've done that here. The next thing we need to consider is the number of degrees of freedom. So we have 5 cells and 1 constraint that is the total frequency. So 5 minus 1 is 4 degrees of freedom. Looking up the value for 5% and 4 degrees of freedom, you can see is circled here, which is 9.488. The next thing we're going to do is calculate the test statistic. So for each O and E, we're going to calculate O minus E squared over E, which I've calculated here. In order to calculate our test statistic, we're going to add those values together, which gives us a value of 1.5453. We need to compare that to the critical value, so as you can see here 1.5453 is less than the critical value, so that means there is not enough evidence to reject H0, which means that the given distribution is a possible model for the data. That's the end of this video. The next video in this series is looking at the goodness of fit test for the Poisson distribution.